Please come in, sit down. While you settle, I will explain that what's on the screen right now is the output of passive DNS. So my company collects the cache miss transactions from over 500 servers worldwide. These are name servers that are used by ISPs, enterprise, university, that kind of thing. And at the moment, we get 250,000 transactions per second, which we deduplicate and filter and eventually reduce down to a usable form. Obviously, 250,000 events per second is like trying to drink water from a fire hose. There's too much. So what you're seeing here is one of many outputs we produce that I find makes a good conversation starter. These are newly observed delegation points. So a delegation point is like a domain name, but it's very specific. It's a domain name you can buy from someone else, as opposed to a domain name inside of that domain, which you would make for yourself. We have a couple of members of the .pt team here today, so they operate a registry. You can probably buy a name from them. Oh, what are we doing here? All right. In any case, most names are not in .pt. I know it's very common here, but around the world, .com is probably the big one. You're seeing a lot of names in .tk, that's the Tokolo Islands. This is a fun display to watch because this represents the actual rate of creation of new delegation points in the DNS. I probably only see half of them, so the rate might be as much as 2 times what you're seeing here, but still, this is how fast the internet grows. And that's something we never knew until we built the system that we have. Anyway, I'm going to talk to you today about DNS, specifically some DNS security matters. I'll come back to this during question and answer, but, oh God, now what? We are in trouble now. I got to unplug the projector for a moment. And then we'll go back. Could you turn me back on, please? Thank you. So, my name is Paul Vixie. I am generally responsible for some software called Bind, B-I-N-D, which I took over from its original authors in 1990, maintained it for 10 years, and then hired other people to rewrite it. So the current version has none of my code in it, but just the same, if you use DNS at all, chances are good that you're using Bind, which is software I once had a big hand in. I've also written a number of DNS-related RFC, request for comment documents. RFC documents are how the internet standards are created. So I've done a lot of work with DNS over the years. I am not here to talk very much about DNS itself because my current job for the last couple of years is to be the CEO of Farsight Security. And we use DNS in our work, but we're not really a DNS company. We're a security company. And I have found that DNS is very important to security. It is either the way someone will attack you or it is the way you can defend yourself in almost all cases. So DNS is extremely relevant to security. So I've moved out of DNS itself, and today I'm going to talk about how to use DNS to defend yourself against internet security problems. Now, I need to I see some DNS experts in the audience, but I think some of you are going to need to know a little bit of background about DNS, but I promise this is not the hard part. So when asked, what is the definition of the internet, a mathematician named Seth Breitbart answered correctly that if you take a bunch of hosts that are able to exchange packets with each other using this protocol, then you need to say, is that collection of hosts the biggest such collection? You have to realize that before the commercial internet, it was the case that most universities, most companies had a small local IP-related network, but they couldn't reach anything outside their own campus or outside of their own corporation. It's only with the advent of Internet 2 and a lot of both academic and commercial interconnection networks that it became possible for everyone to reach everyone. So anyway, Seth's answer was, if you take all of these different collections of hosts that speak this protocol, the biggest one, that's the internet. Everything else is an internet, but there's only one the internet, and that's the big one. And in the time since then, it's obvious which one is the big one. It's the one we're all connected to. But what's interesting is that although this definition is still true, it talks about something that most people never see, right? If you ask most non-technical users, what is the internet, they're going to give you some answer where you, as a technical person, are going to recognize that they just described the web. They didn't describe the internet. And on the web, you don't see IP addresses. On the web, you don't see packets. But the internet is fundamentally made out of packets that have addresses. So the web really is an overlay on top of the real internet, and it hides a lot of the details. And I think it's the web is a phenomenal success. I use it every day. But the internet is older and larger than the web, and we, for the purpose of the next hour, are going to have to remember that they are different things. So to me, the most important overlay of the internet is not the web, but rather the domain name system. And when I say it's an overlay, what I mean is that the things that we see, for example, some name of university.pt or farsightsecurity.com, those are domain names. And they are useful only to the extent that they can relate to IP addresses that you can then send packets to. So always remember, at least for the next hour, that when you're talking about the internet, you're talking about the ability to reach somebody using a packet by putting their address on that packet and transmitting it. So DNS is interesting because it is used to glue the internet together, but it also uses the internet in and of itself. It's a recursive relationship. Now, everything that we do, whether it's web or email or set-top box, watching videos, whatever it is, that everything that we do that uses the internet is likely using the DNS to do so. In the good old days, you used to have to remember an IP address so that you could type that IP address as part of a command. You'd ping it or you'd SSH to it or something like that. Those days are gone. And in fact, they're really gone. There was a time when you would see a domain name on a movie poster telling you, okay, that's batmanforever.com. And you'd know that you'd go home to your AOL connection or whatever it was in those days and type batmanforever.com, and up would come some kind of a web page offering, I don't know, to sell you costumes or something like that. We don't do that today. In fact, that domain name is not on that poster anymore. Nowadays, we use the search engine. Bing, Google, whatever it is you're using. And you know that if you type Batman Forever, it's probably going to take you to the right place. And so you might think that because you're not typing these domain names anymore, and because or at least you're typing them a lot less often, and you're not seeing them very often, that somehow they've gone away. And that's not true. What they've done is they've gone below the surface where you no longer see them. But the only thing that makes that search engine possible is all of the connections inside the web, and those connections are written internally in the form of domain names. So in fact, although you're seeing less DNS these days, DNS is more prevalent than ever. Now, a lot of mobile internet people in particular say, I never type domain names, and it's true. On a smartphone, typing a domain name is so painful that all of the apps are designed to avoid that for you. On the other hand, when you click on something in a search or in your contact box or in your email tool or whatever, it's a domain name that makes that click useful. And so please know that DNS is something that the internet still requires, even if it's not as obvious as it once was. The thing that's fortunate for us in terms of using DNS as a defense vector is that DNS has to be correct. Like criminals need DNS also. And while criminals are perfectly capable of lying about who is, which is a protocol that you used to be able to pretty reliably use to find out sort of who owned a domain name, nowadays criminals can lie about who is. They can use somebody else's address, they can use the address of some stolen credit card, they can use the address of the parking lot next to the hospital at the edge of town, or they can pay some whois privacy service to hide that information. So whois has become useless for defense purposes because it never helps you find the person who hurt you. DNS, on the other hand, you cannot lie about. If you lie about DNS, it won't work. And we use that. Now, it used to be that the elderly generation, the retired folks who were by and large our parents or grandparents, had to worry about crime that was local to them. It may be that if somebody who was 75 years old went to the bank, at least this worked this way in the United States, I don't know how crime works here, they could be seen by some young criminal coming out of the bank. That criminal would assume, okay, you probably went in there to withdraw money. I'm going to, run by and snatch your purse or snatch your wallet or whatever, and possibly injure you during the process of that crime. And that was a problem. And we solved that problem, I guess, by hiring more police. But that was a small problem compared to what that same retired 75-year-old person has today. Because now, any person anywhere in the world can attack that person by planting a keylogger or other malware on their PC using some drive-by download or spam or something like that, and can empty that bank account, maybe in small increments so as to avoid being noticed, and they don't have to put their body at the scene of the crime. They don't have to take any risk that perhaps they will be stopped, apprehended, witnessed, injured. And so the internet has made the whole world a lot less safe than it used to be for those who are the most defenseless. So even though I wish that the internet had been very clean, sort of like in the Star Trek television show, that maybe we build this clean future that everybody is working together just fine, except the bad guys of the week, we didn't. We went into this future, this glorious internet future, and brought the bad guys with us. And what's worse, we gave them a set of tools that they know better how to take advantage of than we do. So we are now fighting a rear guard action. They're behind us, and we are trying to figure out what the heck we're going to do about the fact that the internet works as well or better for criminals than it does for the rest of us. But as I said, we have a couple of advantages when it comes to DNS, because you can't do online crime without it. There's no way to do any of the things I just said about drive-by downloads or malware or infections or keyloggers. You can't do any of that unless you've got DNS. I'm not saying there aren't plenty of criminal assets in what's called the dark network or the dark web, where perhaps DNS is not used. But on the part of the criminal infrastructure that touches their victims, you have to use DNS. And they do this with cheap throwaway domain names. Domain names literally too cheap to meter. Which is what we once said about atomic power. I don't think it's true. There are some DNS registrars in the world who cater almost exclusively to a criminal audience. So they will help you hide your whois. They will help you buy domain names in bulk. They will help you, in some cases, get domain names for free. A lot of the registrars that existed 5-10 years ago have gone out of business because it turns out they actually were criminal enterprises disguised as registrars. But let me quote Francis Bacon here. Nature, to be commanded, must be obeyed. And once you start obeying the rules of DNS, then we can catch you or stop you in some very interesting ways. So this is the last part of trying to explain what DNS is. These are the things you need to know. I'll go through this quickly. Domain names look like something com or example.com. These are places where the owner of names below that point is different from the owner of that name. That's a zone. And your zone, every zone has some name servers. These name servers are themselves domain names. In other words, you're using the DNS to help locate other parts of the DNS. Now, name servers have got addresses, but other domain names that are not name server names also have addresses. I did not show any IPv6 addresses because there's not enough room on the slide to contain them, but these are the old IPv4 examples given. And finally, those IP addresses are grouped together into blocks called net blocks. And you generally write those as I've shown here, but it doesn't really matter how you write them. You just need to know that if two IP addresses are very similar, except perhaps their last octet, the thing after the final dot in an IP address, if they are the same except for that, they're probably in the same net block. And being in the same net block means you might be operated by the same person as the other IP addresses in that net block. You're certainly part of the same ISP, but you might also be part of the same enterprise. So if you can remember this much about the internal structure of DNS, then the rest of this presentation will make a lot more sense to you. I am not here to talk about how to secure DNS itself. A lot of work has been done there. Some of that work has become very effective, and if you are in the business of operating DNS and you don't know what TSIG or DNSSEC is, you probably should go Google these terms. But in any case, this presentation is not about how to secure DNS, but rather how to use DNS to secure other things. So we can come back to any of this in the Q&A period, time permitting. This is how DNS flows. The data in DNS flows. This laptop and your smartphones are examples of a stub resolver. That's the cloud at the bottom there. And it is making a constant stream of DNS requests. It's constantly dealing with some domain name that it needs to know what is the corresponding IP address or mail server or name server or something. It is spewing queries toward the recursive servers right above them. And indeed, those queries and the responses to those queries are what we call in the United States PII, personally identifiable information. And PII is subject to very specific laws all around the world, slightly different laws in each country, but it is protected. You do not want to be, let's say, a bank or a credit card company or an online commerce company that is not following the rules, following the local laws of your country or your region with regard to PII, or you will go to jail for it or pay fines. And as a result of the sensitivity there, a lot of us, myself included, do not like to collect any data down there because then we have to follow all kinds of rules about the personally identifiable information. Now, the name servers that you are sending this PII to, these queries, this continuous spew of questions about, here's my name, what do you know about this name, what do you know about that name, those name servers are operated usually by the same person who is providing you connectivity. In other words, if you have a Wi-Fi connection, it's probable that the Wi-Fi gateway is also acting as a DNS server. Being a DNS server is actually a very small task. You can fit it into a box the size of a Wi-Fi gateway. If it's not in the Wi-Fi gateway itself, then it belongs to the local ISP. Or if you have it's a university, it's probably somewhere on your campus, if not in the same building with you. It's possible to use a global recursive DNS server instead of using the one provided to you by your local Wi-Fi operator or your local ISP or your local enterprise, whatever. Google operates one, 8.8.8.8. We've all seen pictures of some Arab Spring event somewhere where somebody spray painted that IP address on the side of a concrete wall. OpenDNS is a company that makes this service available globally. So indeed, you don't have to use your local recursive server. And by the way, when I was fighting in Washington, D.C. about SOPA, I was trying to explain that if you required all the recursive name server operators to black out names like Pirate Bay, that would simply cause the people who want to get to Pirate Bay to use different servers, and it wouldn't be a very effective law. So this picture was actually crafted for the US Congress, who eventually did the right thing. Anyway, the recursive server has that cache on the left that turns out to be very important for something I'll describe later, which is passive DNS. But the idea is that DNS was designed by academics for use in a network which was used by academics. There may have been 50,000 hosts on the entire internet at the time that DNS was invented. And it's still working. And the reason it's still working is because of that DNS cache. It's because the names that are popular for any given set of users end up being very directly accessible at very low latency. You can access things that have already been accessed very fast. You don't have to go back to the source for everything in the style that we're used to doing on the web. So we have at least 1 billion connected devices now, and DNS is still working as well now as it did the day it was made. And it's, again, that DNS cache is the reason. You will be hearing on Friday, if you come, from Paul Makapetras, who is the inventor of DNS. And so please remind him that I said nice things about his invention. So the authority servers at the top of this picture is where the content comes into the DNS from, by definition, outside the DNS. Generally, it's by editing a text file or a database somewhere and then pointing the name server software at the changed content. So when the recursive server is asked something by the stub that isn't in cache, it's going to get that information from the authority. Now you know everything there is. That is the entire DNS data flow. I didn't hide anything. This is not the simplified version. This is all of it. So that's DNS as it exists. Let's talk about DNS as it is abused by criminals and malcontents. So I mentioned that DNS was crafted by academics in an academic network. It turns out the network itself was crafted by academics. And a lot of people who were in the telco field at the time said, this is a toy and it can't possibly work. Obviously they were wrong, because here we are, we're using the internet. And there are billions of us using the internet, but I'm not sure they were completely wrong, because this picture demonstrates a flaw that was obvious at the time. It's more obvious now, and there is no way to fix it. I tell you this having traveled at least 500,000 air miles for the purpose of trying to convince people to fix it, and I got nowhere. And I'll tell that story in a moment. So what's happening here is that the attacker at the top really wants the target at your left to feel pain. I'm sorry, I put the arrowhead at the wrong end of that black line, but that black line with the small dashes represents a stream of queries that is being sent to a reflector. And there, again, the arrow's on the wrong side. The red line indicates the responses to those questions being transmitted by the reflector. Now you may notice that the queries come from the attacker, but the responses go to the target. How can this be, you would reasonably ask? And it's because the source address of those IP packets that represent the queries, the small dashed line there, has been forged. Sometimes we say forged, sometimes we say spoofed. In any case, they are deliberately wrong. They are set to the attacker's IP address, knowing, as the attacker knows, that the reflector has no way to know that that forgery has taken place. So the reflector has only one choice. It's going to answer these questions or not. And if it answers them, then the target is going to have a very bad day, because those reflectors are enormously powerful. Those authority servers, especially for .com or Google.com or any of the .pt name servers would be another example. They have to be powerful enough that if somebody dumps too many packets on them, they will still be able to answer legitimate traffic. that means they are enormously over-provisioned. They have anywhere from 100 to 10,000 times as much capacity as they would need for their normal non-attack daily load, which means that they are the perfect reflector because they can reflect a gigantic attack without feeling any pain themselves, and that's been happening. Now, other people's networks are generally considered to be the least reliable part of the internet, because you can measure the performance and resilience and accuracy of your network, or even your supplier's networks, or your customers' networks. But once you get to third parties, where you have no contractual relationship with them, you have no idea what they're doing. You have no idea if they have provisioned enough capacity. You don't know how they manage anything. And if let's say you knew that they were doing a bad job of it and you wanted to improve it, there'd be no way to reach out to them and offer to help them pay for it. So other people's networks really are the worst part of the internet from everybody's point of view, and they don't validate the source IP addresses. Going back one page, the attacker's ISP could stop this attack simply by saying, no, you can't forge the source address that is not part of my network. I'm your ISP. I know what source addresses you can use. But they don't. Now, reasons why they don't vary, but it ultimately comes down to asymmetry in the economics. We're asking them to spend money. We're asking them to invest in slightly better equipment, more training, more operational procedures, more break-fix flow charting. They have to do something. They have to take specific action in order to turn this on. And if they don't, it won't hurt them at all. If they do, the beneficiaries will be other people's networks. In other words, their competitors. Now, I can tell you, after a few decades in the business community, that if you go to your board of directors and say, I wish to make an investment and take some risks so that our competitors will benefit from that, generally the board of directors will say, no, you can't do that. And so that's the reason why source address validation does not get deployed. It never helps the network who does it. So, I have made a bit of a career tilting against windmills, getting angry about things that were hard to fix and then doing something about them in spite of that. And this was an example of that. We decided that there had to be some way for that reflector, that name server that had all of that wonderful over-provisioning, had to be some way that it would be able to tell that something was an attack. And it turns out that the attack does look a little different from normal traffic. And that difference is something you are able to determine in real time if you have code running inside the name server. It is, in other words, not something you can do in an upstream firewall. It's not something you can pay an ISP to do for you. Only a name server that is considering whether to answer a question, because it is the authority for a certain part of the DNS, has enough information to accurately decide not to answer a certain query because that query might be part of one of these attack flows. So here's what happened when we put that patch out. A friend of mine from Affilius sent this graph. So let me help you read this. What you can see on the x-axis is time. On the y-axis, you see a zero line and some stuff below the zero line and some stuff above. So the stuff below the zero line is input to the name server. That's queries it is receiving. And the stuff above the zero line are responses that it is sending. And this is in total data volume. This is not the number of queries. This is the number of octets or bytes that represent the queries or represent the responses. And so what you can see here is that they have been answering, starting at the front of this graph, they've been answering around 100 megabits, 100 to 200 megabits of request traffic with around 1 to 2.5 gigabits, in other words, almost 20 times as much in response. Now that's a normal ratio because responses are bigger than queries, but it is a little bit outlandish to think that any name server anywhere, even this one which was for .info, would really be receiving this many queries. This is an unnatural query load. And indeed, when they put our rate limiting logic into their name server on Thursday, what you can see is that the query volume continued as before, but the response volume dropped down to what it should have been. Now, the big fear that an authority server operator is going to have when they put logic like this in that is designed to deliberately not answer certain questions is that perhaps it will have a false negative. You'll end up rejecting something that was not an attack, and you'll get complaints from somebody saying, hey, my domain name is less reachable now than it was before. And .info is not as popular as .com, but it is used for a few things that aren't spam, and so they had a reasonable fear that there might be some complaints, but they got a total of 0 of those complaints. This is now present in not just Bind, where we first announced it, but also NSD and Knot. They all now, every name server that you could get from an open source provider has this feature. You should turn it on, because this was not a single attacker. They didn't have a single attacker running a big attack against a single victim. They had hundreds of attackers running attacks of all sizes against thousands of victims. And there would have been no way to reach in sort of IP address by IP address and to black hole certain things in a firewall or anything else. The only way to get attackers to stop using this name server was to make it completely useless for all attacks, no matter how small. So if you're running any kind of a DNS content server, if you are the example.com in my picture, or if you are the .com in this picture, you should investigate this, because you almost certainly have this logic in your name server. And every time you read in the newspapers about a 400 gigabit per second attack against Spamhaus or Cloudflare or something like that, it's this. It is this that makes that possible. It is the lack of source address validation, and now it is the lack of response rate limiting. All name servers need this. I'm going to make a pass back around to all the name server operators to make this the default. So if their customers, the operators, don't know about it, they'll get it in spite of not knowing anything, because we have to have this. And by the way, this is just the DNS. Once we fix this, they're going to use ICMP and NTP, and it turns out TCP itself has this vector because it doesn't validate the source address for the first SYNAC. So we're going to need to do this for every single protocol, because I'm telling you, it's not going to be possible to get other people's networks to turn on source address validation. So I mentioned that domain names are now too cheap to meter. SpamAssassin was a great teaching tool. If I were designing a sociology experiment, and I wanted to find out what is the best way to educate a lot of spammers that they need to go make domain names cheaper and create a domain name industry that allows them to have domain names that are too cheap to meter. I could not have designed a better experiment than to create SpamAssassin, which is a very successful, very well-written piece of open source software that's used by almost everybody to filter spam, and then have one of the default heuristics in SpamAssassin be that if you use a dotted quad in the body of your email, then it makes you look spammy and causes that message to be likely to get dropped. Because I wonder sometimes what people are thinking, you know, because when you put in a rule that's that easy to bypass, you must be thinking, oh, well, if I make spam hard to send because we'll be able to see the IP address in there, these spammers are going to stop. They're going to stop spamming, they're going to go get a real job somewhere, and the spam problem will be over. I don't know if that was in anybody's head, but it sounds crazy to me when I say it like that, and I can't think of a less crazy thing that could have been in the head of the person who put that into SpamAssassin. Because what we ended up with is the registry to registrar protocol and a whole bunch of criminal registries that then make domain names so cheap that we can just use those instead of dotted quads in the body of our email. So this behavior repeats, by the way. In the United States, when you buy hand soap for the bathroom at your house, you cannot buy it without an antibacterial ingredient, because those ingredients are very cheap And clearly, you would want to have you'd want to kill bacteria. I mean, who wouldn't want to kill bacteria? It turns out that if you kill all the bacteria you can, that the stuff you didn't kill is all that's left, and it has nothing to compete with, and it gets worse and it gets stronger. So we do this as humans. We keep solving the problem that we think we have without thinking about the problem that it's going to result in. If I leave you with no other thought today, it's don't use antibacterial soap or anything in the computer science world that would act that way. You know, think about the whole throw of the lifetime of the technology. So there was a time before the massive commercialization of the domain name system when to get a new .com name, you had to wait a few days. You would register a name, and either next Tuesday or next Friday, whichever came first, the name you just registered would become available. And that, frankly, was fast enough. And nowadays, it's 30 seconds. And it's not just .com, it's all of them. I don't know if .pt does this, but certainly all of the GTLDs do. And you know, it's a bit of a race to the bottom. You know, somebody said, oh, if .com's doing it twice a week, I'll do it once a day. And then maybe people will buy my domains because they're faster. And somebody, .com said, hey, if you can do it in one day, we can do it in an hour. And then, I don't know, somebody else, .biz or whatever, said, if you can do it in an hour, I'll do it in 5 minutes. Eventually, it got down to 30 seconds, and there it sits. And until we get quantum networking or some other faster than light way to send these messages, 30 seconds is the minimum. It's guaranteed by the laws of physics. If it could be less, it would be less. And I would challenge anybody to tell me the non-criminal use of a 30-second turnaround. You know, why would you need that? Guarantee that you're not going to get to the end of some development phase where you're starting a new company and you really need example.com. And oh my goodness, today's the day we're going to launch, and we forgot to register the domain name. Okay, that's not going to happen. So we have built a perfect system for criminal abuse, and it is being abused. What a surprise. So as much as I'd like to prevent the domain names from coming into existence on the far side, that option's been taken out of my hands. Other people have built a system that allows domain names to come into existence with very little latency and very little cost. And so what we have to start thinking of is you know, other ways to get around that, right? You can now pay some companies, security companies, to take down domain names that are hurting you, and that's great, but that'll take 5 minutes. And 5 minutes is all the criminals need, so that doesn't help you. .tk, the Tokelau Islands used to represent half of all new domain name creation events. They've been overtaken by XYZ and some other, but it's basically a URL shortener for criminals. So you can think of bit.ly, except meant for spam. And they set up a system where security companies could register a takedown account with the .tk registry, because the more that these domain names got taken down, the more they would then sell. So they figured that this was a profit center, allowing rapid takedown. So I really just want to say, every time we come up with something, we seem to come up with something that doesn't take into account the bad guy's natural response to what we're thinking about doing. So anyway, can't stop it at the far end. Let's look at some near-end solutions. We can't stop them from coming in. What can we do at our end? And I note that we've been firewalling for decades. There's some argument about who invented the firewall and where it was first used and so forth, but you can't argue that everything is behind some kind of firewall now. There's a firewall on my Windows host, and there's probably a firewall on my Android phone. There are firewalls everywhere. And that's because we know that most of what's trying to reach us is crap, and we would like to prevent that. And so we end up with small rules that say, if you want to reach this server, you'd better be coming from that IP address. Otherwise, we're going to drop it on the floor, that kind of thing. But all these firewalls operate at the lower packet level. There are very few email or web firewalls, for example. So we considered, what about a DNS firewall? And it turns out DNS firewalls work very well. And I was part of the team that created the first distributed reputation system. It's called the RBL. All of you are using the RBL. Every email message, as I look around the room, every email address that you will receive for the rest of your life will have been protected by at least one RBL lookup. You might think I would have patented something that was that valuable, but I didn't. Anyway, it was a way to cause spammy mail servers to be less successful at delivering their stuff. And it, you know, it's, I guess, made the internet usable again, but it's not really solving the spam problem. At least I'm still getting spam today. So anyway, we decided that if it works for mail, it'll work for the DNS. We came up with something called RPZ, which we're very proud of. And this is, by the way, is all open source technology. My company has a few commercial interests in this field, but this is not a commercial talk in that sense. We decided that rather than have it be the kind of firewall that you had to walk up to the console and type in every rule, we would allow all of your name servers to be subscribers to a certain publisher, to as many publishers as they wanted, really. And that would cause all of the name servers under somebody's administration to have the same rules from minute to minute. It would also allow a security company who was aware of certain things that were dangerous to be able to put that awareness into this format and thus publish it and, you know, find an additional revenue source probably. But the idea is to have an unlimited number of publishers and subscribers who are talking in terms of DNS Resolution Policy. You can, if you want, use this to cause failures. You can, in other words, encode a lie. You could say, look, if you look up this name, then I'm going to lie to you, and I'm going to tell you that name doesn't exist. It really does. And if you ask any other name server, it'll tell you the truth. But you're asking me, and I'm lying. Or you might say, I'm not going to tell you that lie. I'm going to tell you a different lie. I'm going to give you a CNAME response, which is an alias in DNS terms, so that even though you looked up, you know, foo.example.com, I'm going to give you back the address of a local web server. I'm going to assume that you are a web user, and that web server will have no purpose in life except to show you an error page warning you of the dangers of clicking on whatever it is that you just clicked on. I've seen it used both ways. Ultimately, this is what the SOPA people were asking us to do. And it was hard to explain in the context of SOPA why DNS blocking would not work when I had just invented this. And a couple of the chiefs of staff of various US Congress people asked me the question, but Paul, RPZ looks like it's perfect for what SOPA wants to do. And I had to explain why that was not true. Ask me in the Q&A if you want to know what I told them. Anyway, there are many ways that you can trigger a rule, and there are many actions that you can take if the rule triggers. And if you're a technical person, you're going to look this up. DNSRPZ.info is one of the URLs you'll find on the final slide in this presentation, so I'm not going to go through these at all. These have been used to stop DGA is domain name generation botnets, because if malware, once it gets into your computer, is going to be using some pre-computed domain name that is based on date and time and so forth, and looks like a lot of random gibberish .info, you could predict all of the names that that botnet is going to be using for the next year and block them all here. And I see that happen. You can also, let's say, if you know that a given LIR that just got another address block from RIPE is actually the same bunch of criminals in the same former Soviet bloc country as the last LIR, and RIPE just doesn't recognize that because they don't have any lawyers in that country, and you just want to make it be that any domain name, no matter what it is, that resolves to an address that is in that /18 should fail, there's a rule for you in here. I certainly recommend that you do this. If you operate a recursive name server, turn this on. Even if you don't want to import any RPZ rule sets from any of the providers that you'll find on my website, make your own. Inside your own NOC, you can create a very short, simple RPZ that you subscribe all of your name servers to, and that way, if you ever have a bad day, and you know that that bad day is related to something that is dependent on DNS, then stick a rule in it, and all of a sudden, you will be working on an internet that doesn't have that in it, which is, to me, what taking back the streets really means. We want differentiated services. We want people who are not trying to hurt us to get better DNS service than people who are trying to hurt us. Okay. How much time have I got? Oh, I appear to be doing fine. All right, need to get to the Q&A. But I do want to say this is what I promised you earlier, is that that picture can be annotated. Here you see us collecting traffic above the recursive. This is what my company does. This is how that display that I was showing you before the start of this lecture works, is that we collect this traffic. We do not collect where the PII is. There's all kinds of cool stuff you can do with a database based on this, and I'm not going to have time to show you that today. This is the limited bibliography. We have about 15 minutes for questions, of which I hope there will be many. All right. I can show what? You want to go through the database? All right, he wants to go through the database. If people start walking out, then we'll know that it's time for dinner. All right, so if you collect all this information and you aggregate it, you can build a really great database. Here is me looking up my own domain name, vix.com. And what you'll see here is interesting because normal DNS works the same way. If you know the name and the type, you ask DNS and it'll tell you what records go with that name and type. With passive DNS, you don't just see the current value, you see the old value. And so here you can see that sometime in 2013, I listed Vix.com for sale. It eventually did get sold, and I used the proceeds to buy a very fine new Miata car. Now, I'm not a criminal, at least as in my own view. But had I been a criminal, and had you been investigating an attack that was related to my domain name, you might be very interested in the fact that I changed my name servers at a certain point. Either I listed it for sale because I needed the money, or more likely, I got kicked off of an ISP due to some complaints. And you, as an investigator, might decide to call my old ISP and ask what those complaints were. So if you're starting to think thoughts about, all right, I'm being attacked all the time by people that are connected to the internet through other people's networks, and I can't deny them connectivity, what could I learn about them that would either make me better able to block them, block their domain names, maybe start a lawsuit against them if they've cost me money, maybe issue a criminal complaint if they have done something that I think is actionable in that way. What you need to do is find out who they are. And since they've hidden who is, you're going to have to find out who they are contextually. You might not start out knowing their name and street address and mother's maiden name and so forth. You might start out just knowing what domain name they attacked you with. But eventually, you'll know all the other domain names that they've attacked anybody with, and that will uniquely identify them in other contexts and will help you figure out how to get recourse against the attacks that have come in. This is an example of how to use wildcards on the client side. Normal DNS has wildcards on the server side. So you could have, let's say you could put in a name like star.com, which would cause all names, all possible names, no matter what they were, to exist under .com. And actually, VeriSign did exactly that a few years ago. It was called the Site Finder debacle. But really, that just synthesizes responses. That's different from being able to look at all existing names. There is really no way to look at all existing names unless they offer you something called zone transfer that is really not very common. But using this system, I was able to ask, what are all of the names ending in .vix.com having type A, which is for address? And you can see I limited this just to my Comcast business connection because there is an overwhelming amount of crap in my personal domain name that would not have fit on this slide. But again, had I been a criminal, then your ability to find out what other names I was using that were related to the one you knew about helps you and hurts me. And there is no way for a criminal to use all of those names without showing up in passive DNS. I am not the only passive DNS company on the internet, although I am the largest. There are plenty of people that are collecting this data, and you should be using passive DNS in any kind of investigations you do. Here we're looking up by the right-hand side instead of the left-hand side. Normally DNS, you look at that, you're doing a lookup for the thing that is on the left. Here I did a lookup for the thing that was on the right, because I wanted to know what are all of the other names that use the same mail server as the one I was looking at. And as you can tell, when I sold Vix.com, I decided to buy property in the Soviet Union, which as a child of the Cold War tickles me no end. So in this example, I was actually not, again, tracking a criminal, but had I been, then knowing what other domain names they were also serving using some mail server that I knew about would, again, help me hurt them. I have many friends now in the FBI. And I thought I would look up their names to find out how clean they were, and I was astonished. They run one of the cleanest IT shops that you can see in the DNS. Our data goes back to mid-2010, and this is all they've exposed in terms of mail. And if an FBI agent ever gives you a business card, it's going to have @ic.fbi.gov on it. So this is their main way of receiving mail from outside their agency. So I thought, again, this is very impressive. What I did is I first said, all right, what's the history of the MX value? Okay. What else uses, what are all the addresses that server has had? And what are any other name that has had the same address? The third example here is looking on the right-hand side. You can't get crisper and cleaner than this. So I was all set to congratulate them until I did this. And I said, did you really have to stick all of the other web servers and project-related name servers in the same IP address block? You're not a criminal, and it doesn't necessarily hurt you, but it's possible that you wanted these to not seem like they were associated with each other. So this, to me, seems like a mistake. They did not have to leak this much information, especially that first one, vpn.dev2. This is... Yeah, I think they've cleaned this up since. So, in all the examples I've shown you, I am letting the command line tool, DNSDB query, convert what it's receiving from the API server into this DNS-like notation, which looks like dig results. And that's because I wrote dig, and I like that notation. But it turns out that that would be really hard to write software for. And so a lot of people turn it off. You see the second example, I added -J. That tells this particular command line tool, don't do any conversion. Just show me what the server is sending you. So you can see that this really is a normal RESTful API with JSON results. So the people who are coding to this standard are using the JSON results. And we decided to write an internet draft about this because we knew that there were other passive DNS projects on the internet, and we wanted it to be that anybody who was a customer of one could be a customer of all of them. So this is not an example of me showing you some proprietary thing that only my company does. So, our passive DNS sensor is open source, relies on PCAP. So if you know what the TCP dump command does, this works the same way. It's looking at packets. And I say it's open source because I intend that people who install it have the ability to audit the code to prove to themselves that I really am only collecting what I say I'm collecting. I encourage any of you who operate a recursive name server to please add this sensor. You will get the immediate benefit of having your network more observed by the security community, but you will also get the benefit of me trying to give you access to some service of ours in exchange for you being willing to run this sensor. The only reason I'm seeing 250,000 cache missed transactions per second right now is because people like you said you wanted to participate in this project. And by the way, since I am at a university, I want to tell you that if you wish to use this data for research, where you don't get paid for the time that you spend using it, and you don't charge a fee for the results you produce using it, in other words, you're a grad student, there will be no fee. You can have access to all of this stuff because we need this data to be more used. We need the internet to be more observed. If you have commercial intent, then we will make a commercial deal with you. But if you don't have commercial intent, then by gum, ask away. You can have this data. But if you're part of a university and you ask for the data, I'm going to ask you to run a sensor in exchange. And that, I think, brings us to the logical end of this presentation. I would like questions. If you don't come up with any, then I'll start calling on people. Okay. All right, this is getting me nowhere. All right, I can't bring that up. About SOPA. What I said is that the Italian government decided at some point to mandate that its ISPs should disallow resolutions, DNS resolutions, for gambling sites, gambling websites that had not been licensed. And the result was the single greatest one-day gain in Google DNS ever, because all the people who wanted to access unlicensed gambling sites in Italy apparently know each other, and so they just told each other, you know, if you switch to 8.8.8.8, it still works. And I asked them the question, all right, so yeah, you could possibly get this whole thing done with SOPA. You could make people install RPZ, and you could publish an RPZ zone, you know, from the motion picture people or whatever. But what do you think they're going to do? Because what I think they're going to do is they're going to use a name server that is not under US jurisdiction. And then I showed them the picture about how much PII would be exposed to name servers not under US law, and asked them if they would like that effect on our economy. So, in other words, you can do whatever you want on the DNS as long as other people want to do it too. So I think RPZ or something like this, some sort of DNS firewalling, is a great feature to have if you're paying for it or if you're subscribing to it deliberately. But if you try and use DNS to behave unilaterally towards someone and make them see only the internet you want them to see, it'll turn out that they have choices. If it isn't Google DNS, it will be, I don't know, a VPN. It'll be Tor. It'll be whatever Google-like DNS comes into existence in, you know, some country that does not follow US law. Doesn't seem like a good way forward. Other questions?
You are also part of the team who wrote the program DIG on Unix.
DIG?
Yes.
Yes.
All right, just to know.
I wrote all kinds of stuff, and I will mention a couple of statistics. I wrote the version of cron that is in all Linux and BSD systems today. And one of the big differences between that version of cron and the previous version of cron is that this one sends you email if your command generates output. The old one didn't. If you wanted the output, you had to send it to a file. And what that means is that I am the single greatest spammer ever born, because my software has sent more unwanted bulk email than anybody else. Let me think what else. I had my own version of SendMail during the time that Eric Allman was semi-retired, and I also put a lot of code into a lot of other utilities. And what that means is that if you look at all of the CERT advisories, all of the different vulnerability announcements about software from about 1985 forward, If you know which ones I was responsible for, which you don't always know because it might have been about SendMail or something like that, turns out I am responsible for more cert advisories than any other single author. So now you can tell everybody you've met me. Over here.
It's not a common practice to have a client's computer make DNS queries to the root servers and the client itself be a recursive resolver, because that would be that would make a heavy load to the root servers. But wouldn't that be a heavy but appropriate solution to the fact that, for example, in Portugal, our DNS is censored? Domains like the Pirate Bay are redirected to an IP address that returns an HTTP 451, and that's ridiculous. If a client could make the recursive DNS queries themselves, that would probably avoid this problem where the ISPs control the DNS queries we make. Is there any widespread solution that avoids this without we having to use Google or OpenDNS servers?
Well, so from the point of, this is a game theory question. So from the point of view of any single user, they lose a little bit of efficiency if they have to run their own recursive server that they're not sharing. And that the loss of efficiency is because they will be looking up names, which in many cases will be the first time that recursive server has been asked, which means you'll have more latency because you won't be getting the benefit of popularity from a larger user base. From the point of view of the internet, however, this is a terrible idea because those caches are protecting the rest of the system. Now, the root name servers are a special case. I, for a long time, operated the froot server. And I'm still one of the operators of the croot server, and I'm in a position to know that most queries that come to the root name servers are unanswerable. In other words, there's a firewall that allowed a query to get out, but will not allow the response to get back. Or it'll be a question for some name that doesn't exist, like .localhost or something like that. And it turns out, when I say most, I mean 98.1%, last time we measured it, of the queries that we receive are unanswerable. And so that means that the part of the load that you're talking about, which is the other 1.9%, could double or triple, or even you could have 10 times as many valid queries and still be in the minority compared to the crap that these root name servers are already built to take. So the root name servers can probably handle it, but I'm not totally sure that everything else can handle it. So you really don't want to do it that way. What you want to do is either use OpenDNS, use Google DNS, or just get together a collection of whoever you would normally drink beer with in the IT field and agree that you're going to all work together to create some shared recursive name server that is outside the country and that, put it on a VPN somewhere, put it in Amazon, put it wherever you want to put it, but then get a certain benefit of sharing and caching among at least a dozen of you, rather than every single person on Earth having to run their own recursive, or every person in Portugal, for example. Now, I have found that a lot of ISPs, and for that matter, a lot of coffee shops or hotel rooms, will block your DNS. So if you try and reach a DNS server that is outside the network, they will steal your queries and answer them locally. Certainly, everyone in China has the problem of the Great Wall, the Great Firewall of China. And so I've worked with some friends to create a tunnel that's not a full VPN and it's not a full Tor tunnel, but it's basically just a way to carry DNS traffic inside of HTTPS. Because HTTPS is almost always allowed to proceed because it involves commerce. And so if you look up HTTP DNS tunnel Vixie, you will find that there is some software out there and there are some well-known servers that you can tie to and that you can probably already do what you want. But really, you should work with the other locals to create shared local expertise and shared local resource. I'm not saying that whatever blocking goes on in Portugal is necessarily wrong, but if you are destined to avoid it, please don't do something worse in your avoidance.
Since you are monitoring the DNS passively, did you see any new pattern after the newly known glibc bug that was made public last week or this week?
Can I have my screen back on the large screen? Yes. So we do monitor quite a bit of DNS traffic around the world. And we do a lot of analysis of it, but of course we make all of this available to the research community, either commercial or non-commercial, and so they probably do more analysis than I do. We have a limited bibliography on the Farsight website of some various technical papers and thesis work that's been done using our data. And applying machine learning to this turns out to be pretty effective. You know, what I myself have noticed is that 90% of everything is CRUD. And if you look at this display and realize how many nights and weekends I've spent staring at 24darling.ru, we really did build this infrastructure, but you know, I guess the biggest surprise was we thought the internet's purpose was to share pictures of cats, but it's not, it's this. So we ourselves don't have any machine learning experts or any other data science type people. What we do is collect the data and do very simple data processing with it to make it available as broadly as possible so that it gets analyzed. But to learn more, you'd have to, again, go to our website, look on the technical info page, and look at some of the papers that have been published that reference our data. Going once. Okay, thank you for inviting me.